Good morning, friends. I welcome you all to our C classroom. So, this is lecture 5 on functions. So, in the previous classes, we have discussed few important things about the functions. How to pass variables of primary data type as an argument to the functions, and how to pass pointers as argument to the functions, how to pass arrays as argument to the functions, how to pass strings as an argument to the functions, and how to pass structures as an argument to the functions, and how to define a pointer to the function, and how to pass one function as an argument to the another function. And in today's class, we are going to discuss how to define a function that returns a pointer, and then what is iterative function, and what is the definition of recursive function, and what are the differences between recursive and iterative functions. And I will give some programs for your practice, and then we are going to discuss about few important questions related to today's class. Let us start our class with functions that returns a pointer. Till now, we discussed that a function can return an integer value to the calling function, a function that can return a float value to the calling function, a function that can return character type values. These things we have discussed. But now we discuss a function that returns a pointer back to the calling function. Pointer means we know that a pointer means it is a variable which holds the address of another variable. Means we are passing a pointer back to the calling function means we are passing the address of a variable of the calling function. And the calling function identifies the contents of that variable using the address passed by the called function. Means here in this case, called function is returning a pointer means it is returning an address of a variable of calling function. And the calling function uses this address to point out the contents of that variable. We know that the content of a variable can be accessible to us by using its address in the memory or by using its name. You can use the variable name or we can use the address where that variable is stored in the memory to access its content. Called function is returning the address of the variable of calling function. So calling function uses its address to access the contents of that variable. Called function is returning a pointer means it is returning the address of the variable of the calling function. That we have to remember. See here the points which were written here. A function like normal variables, it can also return a pointer to the calling function. Pointer to the calling function means the called function is returning the address of a variable to the calling function. Normally this address of the variable is nothing but it is the address of the variable of calling function. That is what we have written in the second point. Pointer means address, because a pointer we have defined it as a variable which points out the address of another variable in the computer memory. So therefore a pointer we are returning means we are returning an address. That we have to remember. Then calling a function must make a call to the called function using appropriate actual arguments. So function to return a pointer, calling function should make a call to the called function. To make a call to the called function, it should make appropriate call using suitable actual arguments. What are to be included in the function call? So function call contains name of the function and then the arguments. If anything is to be passed to the called function, those arguments must be included in the function call. And sometimes the called function may receive arguments and sometimes it may not receive any arguments from the calling function. If it is receiving any arguments from the calling function, appropriate arguments must be passed in the function call. How this calling function makes a call to the called function? Very simple syntax. Here we will write called function name and then the list of arguments we will write here. If any variables are to be passed, v1 comma v2 comma v3 comma and so on, that variables list we will write here. The values of that variables are passed, or address of the variables are passed as an argument to the called function. See example here. We have used a function whose name is biggest. And to that function we are passing the addresses of two variables. What are the two variables? The address of variable A, the address of variable B we are passing. And then the job of the biggest function is which receives the addresses of these two variables A and B. And these variables A and B are belonging to the calling function. The calling function variable addresses it is receiving. Since addresses are passed as an argument to the biggest function, now biggest function means called function is working directly with the variables of calling function. It can access the values of variable A and variable B directly from their locations. And as the name implies, biggest function determines the biggest value of these two variables and returns the address of the variable which is the biggest out of these two variables. That address is being returned by the biggest function to the calling function. Normally here calling function is the main function. To the main function, biggest function returns the address of the variable, whichever is big. If A is bigger than B, then the address of variable A is returned to the main function. If B is bigger than A, then the address of variable B is returned to the main function by the biggest function. So like this, biggest function is defined. This is how the calling function is making a call to the called function. Similarly, a called function must be defined with its suitable formal arguments in the function header to tell the compiler that it is going to return a pointer to the calling function. For that, the return type should be declared as a pointer. Means the return type of the function should be declared with a star. So star indicator means asterisk. Asterisk indicates that this function returns a pointer of appropriate type. So that data type should be returned. Here if you see, the syntax for defining the function header is like this. Return type star. The asterisk means star indicates that this function is going to return a pointer which is of type this return type. Whatever data type you can write here in the return type int star, or you can write double star or float star, telling that it is this function is going to return a pointer which can point out the addresses of integer variable, which can be the address of float type variable, which can be the address of double type variable, which can be address of character type variable, like that, anything. Star is important because this star represents that it is returning a pointer. Pointer means address of a particular variable type. Function name, similar, and followed by function name is followed by the variable names. Variable names v1, v2 with their concerned data types. This is as usual. Only the new thing here is asterisk. This asterisk we have to remember. If you forget to keep asterisk here, it represents that it is a function that returns a simply value of normal variable. If you keep star, it indicates that it is returning a pointer, means address of a particular data type of the variable. Star asterisk star is very, very important in the function header. And this function header, we know, it is there in the function body. And the function declaration is also very similar to the function header, except that the function declaration is terminated with a semicolon. But function header doesn't have semicolon. We have been discussing the same point from the last few classes, isn't it? See, here we have taken an example how the function header is to be defined in the function definition. Biggest function, it is declared that int star means it is biggest function is expected to return a pointer. Pointer means address of an integer variable. And then what it will receive, it is expected to receive two pointers to the integer variables p1 and p2, star p1, star p2. So this star p1, star p2 represent that these are the pointers which point out the addresses of integer variables. That is what we wrote here. Biggest is the name of the called function. It returns a pointer to the integer variable because int star represent in the return type that it returns a pointer to the integer variable. Pointer means address of the integer variable to the calling function. That is what the return type is mentioned. And then p1, p2 are the two pointers to the integer variable which receives the addresses of integer variables as an argument from the calling function. And these two variables are compared for their magnitude, and then biggest function returns the address of the variable whichever is big. If p1 is big, p1 is returned. If p2 is big, p2 is returned. Now, called function must be declared with suitable formal arguments to the compiler to tell the compiler that this called function is going to return the integer type. So it is same as function enter, except that it is terminated with a semicolon, and in the declaration we know that the variable names are option. The syntax for declaration is very similar. Return type star, function name, data type v1, v2. So very similar to the function header, except that at the end you are having a semicolon. See the example of biggest function. Simply you can declare like this with a semicolon at the end. Since variable names are optional here, the names of the pointers p1 and p2 you can remove. Means you can also declare like this without p1 and p2, because in the declaration variable names are optional. Even if you mention, for the sake of remembrance to you, compiler doesn't consider these names in the function declaration. So therefore, whether you keep variable names in the function declaration or not, those are not considered by the compiler. That point we have to remember. Then we will see an example program, how a function is used that can return a pointer. So this program demonstrates how a function returns a pointer to the calling function. We use the same biggest function that receives the addresses of two variables a and b from the calling function. and these variables are belonging to the calling function, and the biggest function works with A and B, compares A and B values, and whichever variable is bigger, that variable address is returned back to the calling function. So calling function here we are using it as the main function. Biggest function is used as the called function. See the point written here. The function biggest will receive the addresses of two variables. That's what I told, A and B or X and Y from the calling function, and returns the address of the biggest variable to the calling function. The two variables, whatever is received from the calling function, they are compared, and finally biggest function returns the address of the biggest variable back to the calling function. See the program, how biggest function is declared in the global declaration section. This is the global declaration section. Our program starts with a include stdio.h, and before that we have to usually write a comment line before include to tell the purpose of this program. So that comment line we wrote here, comment line, and the comment lines are followed by in the next page include stdio.h, and then declaration of function biggest. We have declared that it is taking the addresses of two integer variables from the calling function as an arguments, and finally it returns the address of an integer variable back to the calling function. Then integer main function is starting here. We have declared two variables A and B, and then a pointer called big, because called function biggest is returning the address. To receive that address in the calling function, you must have a pointer, because only a pointer can store addresses. So called function is returning the address of a variable. To receive that address in the calling function, we must have a pointer. Because of that reason, we have declared one pointer here. That pointer name is big, star big. The next statements, see, where we are reading values of these two variables A and B from the user. So for that we wrote one output statement, enter any two integer values. When the users see this statement on the screen, then definitely user will enter two integer values. Till the user enters two integer values, program execution is suspended by the compiler, and when the user enters two values, those two values are read by the compiler, and then it starts executing the program. So scanf statement is reading values and storing those values, integer values. One value is in variable A, and one value is stored in variable B. After reading the values from the user, after storing those values in the two variables A and B, then we are making a call to the biggest function. Biggest, we are passing the address of variable A and address of variable B to the called function biggest. Then biggest function we know, it determines the biggest of these two variables and returns a address of the variable which is biggest. Then that address is stored in the big pointer, because already big pointer is declared as a pointer. Big variable is declared as a pointer which point out the addresses of integer variables. Int star big. This declaration tells that big is a pointer which point out the addresses of integer variables. Big is a pointer which stores the addresses of integer variable. Biggest called function returns the address of a integer variable. So that variable, biggest variable address is stored inside the big. Now when you are making a call to the biggest function, immediately the main function program is suspended there. Control is transferred to the biggest function. The biggest function is declared in the next slide. You can see here. The control is transferred here. It is receiving P1 holds the address of variable A, and pointer P2 is holding the address of variable B. Then the contents of these two variables, star P1 means, star P1 represent that, star P1 means the value stored at the address pointed out by P1. The value stored at the address pointed out by P1 is nothing but It is the contents of variable A is compared with the contents of variable B, because P2 is pointing out to variable B. If P1 is greater than P2, we are returning the address of P1 because P1 is bigger. Else means if this condition is not true, means if it is false. False means P1 is not bigger than P2. P1 is not bigger than P2 means P2 is the bigger. So therefore we are returning P2. So program is terminated here with this statement. Means either it returns the address of P1 means variable A, or it returns the address of variable B. So these addresses are passed back to the calling function. In the calling function, this address is stored inside the variable big. Big is a pointer. Now we will print the contents of the value stored at that address. The biggest value is star big. Star big means the value stored at the address pointed out by the pointer big. Usually pointer big point out the biggest value, and then program is main function is terminated. So like this you can use. Means this function called function is declared to return a pointer, means a pointer which can point out the addresses of some integer variable. Here the task of the biggest function is to return the address of the biggest variable. Like that we can use. Then we will go to the second concept, that is iterative function. What is an iterative function? Iterative statements already we discussed. What do we mean by iterative statement? Iterative statements means these are the statements which are used to execute some set of statements repeatedly, either a fixed number of times or until a condition is made false. Till the condition is made false, the set of statements are going on, repeating. For that purpose, we have used iterative statements. Iterative statements are also called looping statements. We discussed three types of iterative statements, three types of looping statements. What are they? One is while loop, and another one is do while loop, and another one is, third one is for loop. These statements are called while loop, do while loop, for loop. These are called iterative statements. Iteration means executing a set of statements repeatedly, either a fixed number of times or until a condition is made false. Till that time, set of statements are going to be executed. Similarly, what do you mean by iterative function? Iterative function means it is a function which executes some set of statements repeatedly to perform a task. Such functions are called iterative function. Iterative function, again I am defining. Iterative function means it is a function that executes a set of statements repeatedly, either a fixed number of times or until a condition is made false. Till that time, it goes on executing a set of statements. Such functions are called iterative functions. To execute set of statements repeatedly, iterative function makes use of iterative statements, means looping statements. Let us see the definitions here. Iterative function is a function that makes some part of its code to be executed either fixed number of times or until a condition is made false. Till that time it goes on executing the set of statements. For that, it uses one of the looping statements. The looping statements can be for loop or while loop or do while loop. It can use any one of these looping statements to execute the set of statements repeatedly. We will take an example where a set of statements are to be executed repeatedly to accomplish a task. One example is to calculate the factorial of a given integer. So there you can use iterative function. Since factorial of a number can be expressed as a series of repeated multiplication, iterative function can be used. Suppose you wanted to determine the factorial of n. Factorial of n is nothing but it is a multiplication of all the integers between 1 and n. So 1 is multiplied with 2, 2 is multiplied with 3, and so on up to n. All integers. Factorial of n is nothing but it is the multiplication of all integers from 1 to n. That is called factorial. So for that you can write a iterative statement like this. Fact variable. It is assigned initially value 1. Then for I equal to 1 to I is less than or equal to n, I plus plus. Fact is equal to fact into I. So since initially fact value is 1, 1 into I value is initially 1. 1 into 1 becomes 1 is the new value for the factorial. Then I value becomes 2. 2 is less than or equal to n. N value you can take it as a 4. 2 is less than or equal to 4. Since condition is true, again this statement is executed. Fact is equal to old fact, value of fact is 1, 1 into, now I value is 2. 1 into 2 means first two integers are multiplied. 1 into 2 means 2 is the product. 2 is assigned to the factorial. Then I value is incremented. Previously I value is 2, now it is incremented by 1. Means I value becomes 3. 3 is less than or equal to 4. Condition is verified. Condition becomes true because I value is 3. 3 is less than or equal to 4. Then fact value becomes, fact is a new value of fact equal to old value. Old value is 2. 2 into 3. I value is 3 now. 2 into 3 becomes 6. And 6 is stored as the new value for the factorial, fact variable. And then I value is incremented by 1. Previously I value is 3. Now it becomes 4. Again it verifies the condition. 4 is less than or equal to n value is also 4. 4 is less than or equal to 4. Condition is true. Again it executes statement. New value of fact equal to old value. Old value is 6. 6 into present I value is 4. 6 into 4, 24. 24 is stored in fact value. Then I value is again incremented. I value becomes 5. 5 is less than or equal to 4. Condition is verified. Condition becomes false. So it stops. When the condition becomes false, then the set of statement. Here we are having only one statement inside this set of braces. That statement is executed repeatedly until I changes from 1 to n. Means all values of integers are multiplied one after the other starting from 1 to n. And this product, temporary product, is stored in variable fact. And when this condition becomes false, finally the fact contains the product of all the integers from 1 to n. So that value can be printed. Like that we can use this iterative statement inside the function to calculate the factorial of a number. We can use fact of n, which receives an integer as an argument and calculates the factorial by performing series of multiplications. That is how we can use factorial function. So in its body it uses this for loop for calculating the factorial of n by executing a set of statement. Here we are having in the set only one statement inside the for loop. To perform series of multiplication, it executes a set of statements repeatedly until all the integers from 1 to n are multiplied. That is what we have discussed just now. See how the fact n function is declared. Its return type is declared as long integer because the product of 1 to n integers is to be returned. So normal integer, if you use the product value, may not fit into the normal integer variable. So therefore we have defined long integer variable. Return type as long integer. Long integer occupies the storage double the size of the normal integer variable. Then fact int n. Int n means it receives an integer value as an argument from the calling function. So for that n value it determines the factorial. So inside the factorial function we have defined variables long int I, a variable ft which is assigned initially a value 1, calling the factorial function n. See, calculating the factorial of integer n using an iterative statement. Inside this iterative statement we are having only one statement that is going to be executed for a fixed number of times. How many times this statement is executed? N times, because I value is changing from 1 to n. So as long as I value is changing from 1 to n, this statement is going to be executed. Ft is equal to, means the new value of ft is equal to old value of ft into I is going to change from 1 to n. So every time I changes, its value is multiplied with the ft, and that product is assigned as a new value to the ft value. So this statement is going on executing just now as we discussed here. Same statement we wrote there. Whatever statement but here the variable name we have taken as fact. Here we have taken the variable name as ft. Same statement. Fact is replaced with ft. That's it. So this statement is going to be executed n number of times. Means fact function is executing this statement n number of times to calculate the factorial of n. And finally the ft value. ft contains finally the product of all the integers from 1 to n that is being returned. ft is a long integer. It is declared as a long integer value. And function is also declared to return a long integer value to the calling function. That is returned. So using this concept, we will write one program using same fact function to determine the factorial. See, our program starts with a always documentation section which tells the purpose of the program. This program calculates the factorial of a given number using a iterative function. What is that iterative function we are using? Fact of n is an iterative function that receives an integer value as an argument from the main function, and then it calculates the factorial by performing series of multiplications and returns that factorial value to the main function. Then main function will print that factorial value given by the called function fact. Here we declare the called function that returns long integer value. It receives an integer value from the calling function. That value is stored in n. Now see, main function is starting here. Inside the main we have declared a variable int n for whose value we have to determine the factorial. Long int ftr, some variable ftr, because this is declared, it is required because ftr is going to hold the value given by the factorial function. Whatever value is returned by this factorial fact function, that value is stored in the ftr. Since fact function is declared to return a long integer value, we need to have a long integer value to hold that long integer type of value. So for that purpose we have declared ftr function in the main program. Now see, we are reading an integer value from the user. We are asking the user to enter some positive integer value. User will enter that positive integer value. That value we are storing in n. Once you know n value, then you can pass that n value to the fact function. We are making a call to the fact function by passing n value as an argument. Then factorial fact function will calculate the factorial of this variable n and returns that value. That value we are storing in ftr. Once you are making a call to fact function, this main function is temporarily suspended for its execution, and control from this statement it goes to the fact function. Fact function is defined in the next slide. See how fact function is declared. It is defined to return a long integer value. It is receiving an integer value as an argument from the calling function. That value it is storing in variable n. And then inside this function we have two more variables, that is I and ft. ft is initially assigned with a value 1, and I is keeping track of all the values from 1 to n. They are being multiplied, and all that temporary product is stored in variable ft. And finally, when I value changes from 1 to n, when I reaches n, ft contains the product of all the integers 1 to n, and that is stored in ft, and that value we are returning to the main program. So this function, fact function, is returning ft value, and that ft value whatever it is returning, that is being stored in the main function ftr. Once a fact function is terminated, control is coming back to this statement where fact function is returning the product of 1 to n integers, means factorial. That value is stored in variable ftr. Fact is returning long integer value, and ftr is also declared to store a long integer value, and then we are printing that long integer. Factorial of %d is equal to %ld. LD means long, since it is long integer value, product is a long integer value. So we have used format specifier LD to print a long integer value. And in this %d, n value is printed. N is declared as a normal integer. So therefore %d means decimal integer. %d, decimal integer value of n is printed here. %ld, here second variable value, ftr is printed. ftr is declared as a long decimal integer. So LD, format specifier LD is used. Program is terminated. This is how a iterative function is used to perform a specific task by executing a set of statements repeatedly. That is called iterative function. Iterative function always executes a set of statements by using a iterative statement. That we have to remember. Now we will move to a third concept called recursive function. What is recursive function? Recursive function is also used to execute a set of statements repeatedly. But for executing this set of statements repeatedly, it makes a call to itself. By making a call to itself, it executes a set of statements repeatedly. Iterative function is not making a call to itself. It is using a iterative statement, means looping statement, to execute a set of statements repeatedly. But a iterative function, same set of statements, it executes repeatedly by making a call to itself. Every time it is called, whatever code is there in its body, it is going to be executed. How these recursive functions are being implemented? See the statements written here. It is also similar to an iterative function used for executing a set of statements repeatedly by making a call to itself. It makes a call to itself. Any function which makes a call to itself is called a recursive function. A recursive function is defined to make a call to itself. Suppose, see one simple example. Main. Inside the main function, we are printing a statement. Like this is an example for recursion. And immediately we are making a call to main function. When you are making a call to main function, what happens? Control is transferred from main function from here again to main here. What happens? Again, main function is called. Again, this set of statements are, this statement is executed. This is an example. Then again, it will make a call to main. Again, it goes and making a call to main. So therefore, again, main function is executed. So this goes on executing. And this program never be terminated. So every time it is making a call, it is printing this statement. This is an example for recursion. Like that, this goes on printing here. How many times it is printed? So many times it is printed. So therefore, a recursive function must have some condition to terminate. Otherwise, what happens? It goes on executing forever. The program never be terminated. So then your system will enter into an infinitive loop. It goes on executing. The program never finishes its execution. To stop the execution of such programs, then you have to press on the computer either Control C or Control D. It is nothing but an interrupt you are sending to the CPU to stop the program suddenly, because that program never be terminated. So therefore, by pressing Control C or Control D, you are generating an interrupt. Interrupt means it is a signal which is going to give a message to the CPU to stop whatever program it is executing currently. Immediately, once the CPU receives that signal, it is terminate the program, whatever it is executing. Because that program can never be terminated in a natural way, because that program doesn't have any statement to stop its execution. So therefore, we are using external sources, interrupts, to kill that program. Here, final conclusion is every recursive function must have some terminating condition. Otherwise, it goes on executing. Because it is making a call to itself, it goes on executing some set of statements. Usually, recursive function contains a if conditional statement to terminate that function at some point. Means at some point of call, that function is going to be terminated. Recursive functions are widely used in the places where the solution of a problem can be expressed as the repeated application of the same solution to the subset of problems. Wherever you are having the problem where a solution is expressed as a repeated application of the same solution to its subset of problems, there you can use the recursion concept to solve such kind of problem. Means a big problem, if you have to solve, that solution is you are having some method to solve that big problem. But a big problem cannot be solved directly. So normally we will divide that big problem into many small subproblems. To get the solution to the small problems, we will use the same method. Whatever method we use to solve big problems, same method we will apply to solve subproblems P1, P2 up to Pa. So same methodology we use to solve subproblems. When you combine the solution of all these subproblems, you will be getting the solution to your big problem. Means the solution of the big problem is used as a solution for all its subproblems. Wherever the concept is like this, there you can use the recursive functions to solve such problems. We'll take one example. Suppose if you want to determine the factorial of a given number, the factorial of a given number in mathematics can be expressed as a repeated solution like this. Factorial of n is nothing but it can be written as n into factorial of n minus 1. Example. Suppose n value is 4, then factor of 4 is nothing but 4 into factor of n. Means if you wanted to determine the factorial of 4, the factorial of 4 is nothing but 4 multiplied with the factorial of 3. Means you should know the factorial of 3. If you know the factorial of 3, that factorial of 3, if it is multiplied with the 4, you will get the factorial of 4. And see, factorial of 3, again, using the same concept, this statement. It can be written like this. Factorial of 3 is nothing but 3 into again factorial of 2. Again, factorial of 2 is written using same concept. 2 into factorial of again 1. Factorial of 2 is nothing but 2 is multiplied with factorial of 1. Factorial of 1 we know 1. So finally factorial of 1 is 1. 1 multiplied with 2 gives the factorial of 2. Factorial of 2 when it is multiplied with 3, it gives the factorial of 3. And this factorial of 3 if it is multiplied with 4, it gives the factorial of 4. So that is nothing but 4 into 3 into 2 into 1. Finally factorial of 4 is value 24. So like that we can use the solution. So wherever the solution to the problem is expressed as a repeated solution of the subproblems, there we can use the recursion concept to get the solution to the problem. We can use fact n, which receives an integer as an argument from the calling function and calculates factorial by performing series of multiplications. To perform this series of multiplication, it executes a set of statements repeatedly until all the integers from n to 1 are multiplied by making a call to itself. So fact function, now we are here implementing such that this fact function is making a call to itself repeatedly until all the integers between 1 and n are multiplied. See how this fact function is implemented using a C code. Fact function, same fact function we have implemented using iterative concept in previously. Now we are implementing fact function using recursive concept. Fact function is making a call to itself here. It is making a call to itself. See, fact function finally returns long integer value. Since it is a recursive function, definitely it must have some conditional statement. Otherwise, this function is going on executing, it never be terminated. To terminate it, definitely you must have some condition, if condition. So whenever that if condition is satisfied, then it will stops making a call to itself. At that place, it returns control back to its previous call. From there, it returns the control back to its previous call. Like that, it goes on. Finally, control is coming back to the main program. See here, inside the fact function, we have defined a variable ft, which is of type long integer, because ft is used to store the intermediate products. This product may be a long integer value, so therefore we have defined it as a, to hold that intermediate product, we have defined ft as a long int. Normal integer variable, sometimes it may not be suitable to hold big value, because normal integer value on most of the systems, computers, it can store a maximum of 32,768 value. If the product generated is more than 32,768, it cannot hold that value. So therefore, we can go for long integer value. So long integer value can hold the values up to 65,535. So more than that, it cannot hold. Okay, so that is how we have to declare. If product generated is more than 65,535, so then you can go for other data type, which can hold still bigger values. Means you can go for unsigned long integer, which can hold double the range of long integer values. So based on for which number you are determining the factorial, so that data type you have to declare here. So here we are using ft as a long integer variable. See, we are checking for the condition. If n value equal to 1, simply it returns 1 and it doesn't make a call to fact function itself. But if n value is greater than 1, then it is defining the factorial like this. ft is equal to n into, means the value n is multiplied with the factorial of n minus 1. Means it is making a call to the fact function itself with a n minus 1 as an argument. Means again fact function, from this statement again fact function is called with a value n minus 1. If n value is 4, that 4 is multiplied 4 into fact of 3. Fact of 3 means fact function is again called with a value 3. Again this statement is verified, n value is whether it is equal to 1 or not. If since fact function is called with a value 3, so this statement becomes false, then it makes again call to fact, means n value is 3 into fact of 2, means again fact function is called with the value 2. N value is 2. Since n value is 2, 2 is not equal to 1, this condition becomes false. Again fact of 2 is nothing but ft is equal to 2 into fact of 1, means again fact function is called with the value 1. So n value becomes 1. So n is equal to 1. So therefore 1 is equal to 1, it returns 1. Like that this goes on executing. And finally it returns ft function. How this function is going to be executed? See here, n value is verified everywhere. N is equal to, whenever n value is equal to 1, then it returns 1 and it doesn't make a call to itself. But when n value is not equal to 1, its factorial is expressed as a repeated multiplication of itself by making a call to itself. See, the explanation is, suppose n value is 4. Initially we are making a call to fact function with the n value as 4. What happens? It will check first this condition, n value whether it is equal to 1 or not. Since n value now it is not 1, it is 4. 4 is equal to 1, statement becomes false. Then it executes this statement, ft is equal to 4 into fact of 3. That is what we have. ft is equal to 4 into fact of 3. Means again you are making a call to fact function with a n value as 3. Again it will check the condition. 3 is equal to 1? No. So therefore again ft is calculated. Means this is another call with another variable ft. ft is equal to 3 into fact of n minus 1. N minus 1 means 3 minus 1. So 2. Again it is making a call to ft function, fact function with n value 2. Again it will check the condition. 2 is equal to 1, it becomes false. So again ft is equal to 2 into fact of 2 minus 1, means fact of 1. See, factorial 2 need to be calculated. Factorial 2 is nothing but fact of 2. To determine the factorial of 2, again it is making a call to fact function with n value as 2. So when n value is made with 2, whenever it is called, what happens? See here, n value 2. 2 is equal to 1, false. So ft is equal to 2 into fact of 1. That is what factorial of 2 is equal to ft equal to 2 into fact of 1. Means factorial function is called again with a n value as 1. See here, when n value is 1, with n value is 1, it called, and since n value equal to 1, 1 is equal to 1, so it returns 1. A value 1 is written by fact function, and that value n is substituted here, 1. Fact of 1, whenever it is called with the fact of 1, fact of 1 returns 1. That 1, this 1 is placed here. So 1 into 2, 2 is the result of ft. So fact of 2 call returns this ft value, 2 value. That 2 value is substituted here in the place of fact of 2, because this fact 2 make returns a value 2 to the previous call. 2 into 3 is multiplied. Result becomes 6 when this is multiplied. 6 is the value of ft. So value of ft is returned by fact 3 function to the factor 3. 6 is returned. So 6 into 4 is multiplied. 24. 24 is the value of ft in the fact function whenever it was called with the 4. This ft is returned to the main function. In the main function, ft value is printed. So complete program implementation is like this. This program calculates the factorial of a given number using recursive function, fact. Fact of n is a recursive function that receives an integer as an argument from the main function. It calculates the factorial by performing series of multiplication through repeated calls to itself and returns finally factorial to the main function. That is how it is done. Same declaration of fact function. It is declared to return a long integer value. It is expected to receive an integer value from the calling function. Then main function, inside the main function, ftr is long integer variable, n is normal integer variable. First we will be reading value of n from the user, and that value we are storing inside variable n. Then we are making a call to fact function. Whenever you are making a call to fact function is called. Control is transferred there. So same code. It calculates the factorial as we discussed previously. Same code we wrote here. Finally, fact function returns ft value. That is, if n value is 4, factorial of 4 is 24. Value 24 is returned back to the main function. That value 24 is stored in ftr. We are printing the content of ftr variable here. So means whatever program, factorial program we wrote previously using iterative concept, same function we have implemented now using a recursive function, because factorial of a given integer can be expressed mathematically as a series of multiplications with the same concept. So therefore, wherever the solution of a problem is expressed by applying the same solution repeatedly to its subset of problems, there we can use recursive function. So recursive functions are widely used to solve so many problems in computer application. To solve so many mathematical problems, we can use recursive concept. Means function problems can be solved using iterative concepts, or problems can be solved using recursion concepts. Whichever is easier for us, that we will use. That concept we will use to solve the problems. But here, each method we are having its own limitations. If you consider recursive functions, they have so many limitations. First limitation is it is overhead to the CPU. Why it is overhead to the CPU means CPU is made busy uselessly. Means CPU is doing busily some work which is not required for us to perform our computational task. Why means in recursion a function is making a call to itself. When a function call is to be made, if you are aware of operating system concepts, whenever a call is to be made to the function, immediately what the CPU has to do is CPU has to perform a context switching from one function to another function. Making a call to itself is also considered as making a call to other functions. It is very similar to function 1 is making a call to function 2. But here function 1 and function 2 are same functions. But anyway, the context switching need to be performed. Whenever CPU wants to move from function 1 to function 2, it should store the function 1 variable values temporarily onto the stack, and then it should store the return address of the instruction which is going to be suspended for its execution now. That instruction address to be pushed onto the stack, and all the intermediate results computed so far are to be stored on the stack, and then it has to move to function 2. And all these works it has to do, and this is not required for us. Since function is repeatedly making call to itself, so every time it has to do all these housekeeping works. So therefore CPU is doing more work in pushing all the values onto the stack and then going to the function, switching to the other function. It is a headache to the CPU. That is what CPU is unnecessarily made busy. That is the first limitation. Second limitation is it occupies a lot of space in the computer memory. Why it is occupying a lot of space in the computer memory means it is storing, we are not only storing variable values. So we are storing in the function call every function, whatever values temporarily it has been computed and its variable values and its return address of the instruction. All that we are pushing onto the stack. Stack is nothing but some space in the memory to move from one function to other function. Yes, in every function call, it has to store all these values onto the stack. Stack means some space in the computer memory. So this space is not really it is required for us to perform our task. But unnecessarily so many variable values are pushed onto the computer memory in the function calls. So therefore it occupies a lot of space in the computer memory. Then for complex problems to solve, it makes so many calls. So therefore it is very difficult for us to use because it keeps a lot of burden on CPU, occupies a lot of space in the memory. So therefore to solve complex problems, normally it is very difficult. It takes a lot of time for the CPU to execute. So therefore recursion concept is used wherever it is necessary. Means when you do not have any other way to solve that problem, then only we are going to select the recursion concept to solve the problem. If the problem can be solved using other ways are there, or using a iterative concept, the code can be written, then we can use iterative rather than a recursive concept, because iterative concept doesn't keep any burden on the CPU, it doesn't occupy any space in the memory, and it is easy to solve the complex problems. Suppose if the iteration concept is not suitable to solve the problem easily, then only we will depend on recursive function concept. Otherwise we do not go for recursion, because recursion is having so many problems internally to the computer. We cannot see all these problems, but first to the CPU it is a headache. It is a overhead to the CPU. So therefore recursion concept methodology is used to solve the problem wherever it is necessary. If the problem can be solved with other ways, then we will go for other ways rather than going for recursion concept. Recursion is used to solve the problems where the same solution is used for subset of problems. There we use recursion, but as far as possible we will try to avoid using recursion concept. So after having the idea of recursion and iteration concepts, then we will discuss few differences between iterative function and recursive functions. What are the differences between iterative functions and recursive functions? Both functions execute same set of code repeatedly to solve a problem. But what are the differences? See the first difference. Iterative function executes a set of code repeatedly by using looping statements, but a recursion function executes a set of statements repeatedly by making a call to itself. It uses iterative concept uses less space in the memory, but it uses more space in the memory. Iterative concepts make CPU only little busy in doing computational works, but a recursive concept makes the CPU busy doing context switching. Context switching means saving the values of the variables and saving the return address of the instruction and then saving the values that are generated or the values that are computed so far onto the stack. All these values are being stored and then it has to move from one function to other function. That is called context switching. So means during this process, context switching process, the contents of so many CPU registers like program counter value and then stock pointer value, base pointer values and the contents of AX register, BX register, CX register, source index pointer, destination index pointer, so many register values are to be pushed onto the stack and then it has to perform context switching. It will take a lot of time for the CPU. CPU is made unnecessarily busy in doing all these works. And it uses CPU time efficiently, iterative concept. But in recursion, it is making CPU busy uselessly, so therefore it will waste a lot of CPU time. And iteration concept is very easy to the CPU to perform. But the recursive function is a lot of burden to the system. That is what we have discussed. So these are the few differences, and after listening to iterative concepts and recursive function concepts, if you get any more points which you feel that it is also a difference between iterative function and a recursive function, then you can add those points to this table. And this question was asked many times. What is recursive function? And explain the recursive function with an example. That was many times it was asked in the exam. So therefore recursion function concept is very, very important. Similarly, the differences between recursive function and iterative function was asked as a short answer question many times in the examination. So therefore these differences between iterative functions and the recursive functions is also very important. Then some exercise programs. These programs, because already we discussed few programs. One program on iteration, one program on recursive concept. And one program we have discussed on how a function can return a pointer. So after going through these programs, you can do these programs as an exercise. See, first program is write a program using an iterative function sum to determine the sum of first n positive integers. Means if n value is 10, you have to determine the sum of first 10 integers, 1 to 10 numbers you have to add, their sum you have to compute. Using iteration concept, simply you can write a for loop for I equal to 1, I is less than or equal to n, I plus plus. Sum is equal to sum plus I. Like that you can write. Initially sum is assigned value 0. Like that you can. After doing this loop, then you can return some value to the main function. Then second program, write a program using a recursive function sum to determine the sum of first n positive. Same sum function you are using with a recursive concept to calculate the sum of first n, because this sum of n is nothing but n plus sum of n minus 1. You can write like that in mathematics. So therefore you can write a recursive function. Little bit, if you think, you can implement this sum function. Write a program using a recursive function fib to determine the nth Fibonacci number. So this program was also asked many times in the examination. This is important. Fibonacci series means a Fibonacci series is like that. In Fibonacci series, every number in a series is obtained by adding previous two numbers in the series. Fibonacci series starts with 0, 1. First number is 0 in Fibonacci series and next number is 1. Third number, if you wanted to get, you add these two numbers, 0 plus 1. 1 is the third number. Now if you means 0 1 1 you got. Now if you wanted to get fourth number, you add third number and second number. Third number is 1, second number is also 1. So 1 plus 1 you will be getting 2. So 2 is the fourth number. If you wanted to get fifth number, you add fourth number and third number. Fourth number is 2 and third number is 1. So 2 plus 1 becomes 3. 3 is the fifth number. If you wanted to get sixth number, you add fifth number and fourth number. You will get sixth number. Like that, Fibonacci series is there. So you can use this concept to implement Fibonacci series. Then fourth program is write a program using recursive function TOH that gives a solution to the Tower of Hanoi problem. Towers of Hanoi problem. So it is a different concept. Towers of Hanoi means where you are having three rods. Rod A, rod B, rod C, vertical rods. So assume that rod A contains some stock of discs with larger disc is at the bottom and smaller disc is at the top. Our problem is we have to shift all this stock of disc from rod A to the rod B or rod C, same stock of disc. So while shifting all these discs, stock of disc from rod A to either rod B or either rod C, you have to follow three conditions. The first condition is you have to move only one disc at a time from any rod to any rod. Only one disc should be moved. That is the first condition. Then second condition is when you are picking up a disc from a rod, you have to take only the top disc from the rod. The disc which is there on the top, that you have to take to move. That is second condition. Third condition is when you take the disc and when you wanted to keep on other rod, either on rod B or rod C. Okay, so you have to see that the larger disc should not be kept on a smaller disc. That is the third condition. Again, I am repeating the conditions. Three conditions. Only one disc can be moved at a time from any rod to any rod. Second condition is when you are picking up a disc from any rod, you have to take only the top disc. Usually the top disc is the smaller disc because the discs are arranged always from larger at the bottom and then at the top smaller. In that order, larger to smaller, the discs are kept on the rod. That is the second condition. So whenever you are picking up a disc, you have to pick up only the top disc from the rod. Then when you are keeping a disc on any rod, you have to see that larger disc should not be kept on a smaller disc. So like that, finally our aim is to shift all the stock of discs which are there on rod A either to rod B or you can shift it to rod C. Suppose your aim is to shift all the stock of disc from rod A to rod B. Then you can use rod C as a temporary storage. You can take disc and temporarily you can keep. But when you are keeping temporarily also, you have to follow all these three conditions. Okay, only one disc can be moved. And when you are picking up, only top disc should be picked up. And then when you are keeping disc, larger disc should not be kept on a smaller disc. These three conditions everywhere you have to follow. And finally, the entire stock of disc from rod A to be moved to rod B or rod C. You can move to rod B or you can move to rod C. Whatever arrangement is there in rod A, same arrangement should be there on rod B or rod C. Like that you have to do. So that is the solution. Here the solution is nothing but you have to give a solution in the steps of moving the disc. Rod A, assume that it contains three discs. Larger disc is at the bottom on rod A, and above the larger disc, medium size disc is there as a second disc, and then smaller disc is there as a third disc at the top. So discs are arranged from larger to smaller on rod A. So all these three discs should be moved to, assume that you are moving to rod C. So in the same arrangement you have to get. So what are the steps? How to move discs? You give numbers to the bottom disk number 1, middle disk number 2, and smaller disk on the top number 3. 1, 2, 3. 1 is at the bottom, 3 is at the top. The disk 3 is, number 3 disk is smaller disk, number 1 disk is larger disk is at the bottom. Now our aim is to shift all these disks from rod A to the rod C. In the same order it should be kept on the rods. In every moment these 3 conditions whatever I said are to be followed. So using recursion you can implement that program. Some of the important questions related to this topic are: explain how a function returns a pointer to the calling function with an example. So that is the first concept we have discussed in today's class. And the second question, define a recursive function. Explain how it is used to generate Fibonacci numbers. Recursive function you have to define, and then you have to explain the program of generating Fibonacci series using recursion. Then third question, what is recursion? Write a C program for towers of Hanai. Also specify the diagrams for its movements, how the disks are moved. Assume that you are having 3 disks on rod A and you give the diagrams, how you are step 1 diagram, step 2 diagram, step 3 diagram. So usually to move 2 disks, how many steps are involved? Okay, so carefully give the steps one after the other. Your program, when you write a program, your program should give the steps as the output, how to move. Which disk is to be moved from rod A to rod B, and rod A to rod C, or rod B to rod C, or rod C to rod A or rod B, like that. The program should give the steps, how to move the disk to shift all the rods from rod A to rod C. Using recursion, you can write the program for towers of Hanai problem. Then fourth question, how does a recursive function differs from an iterative function? Discuss. So this was also asked in the previous exam. Differences between iterative function and a recursive function, that you have to discuss thoroughly. So these are the assignment questions for this class. So try to write the programs for question number 2 and question number 3. They are very, very important. Question number 1 and question number 4 are theoretical questions, so which were already covered in our today's class. So please write these answers for these questions and submit the assignments by tomorrow 1 p.m. Okay, thank you all for your patience listening. Okay, so once again thank you to you. In next class we are going to discuss about the dynamic memory management techniques, how the memory can be allocated dynamically, means during the runtime of the program, and how it can be freed up during the execution time, means dynamic memory management, means at the time of running your program, how can you allocate the space to the variables, required space to the variables, and whenever you don't need the memory, whenever how to release that memory dynamically at a runtime. So that we will discuss in the next class. So this concept, allocation of memory or freeing the memory at a runtime, it is called dynamic memory allocation techniques, that we are going to discuss in the next class. Thank you all once again.